Hello and welcome to Rebel Way and our Python for Houdini Artists workshop. Let me start by introducing myself. My name is Ciro Cardoso. I am a lead and a senior general artist, and for the last 16 years or so, I had the opportunity to work in multiple industries, from architectural to product visualization, and also animation and visual effects. I have the pleasure over the last couple of years of working with some incredible studios like Axis Real Time, and I'm currently freelancing with Goodbye Kansas. Now, I'm very excited for this opportunity to be your guide and mentor for this workshop because programming is something that I've been doing since the start of my career. My journey with programming started with a language called C, and I was doing very simple tools, nothing special. And then when I got my first job in the industry as a lighter in Maya and Mentorway, that's when I saw the potential of using programming to help me to be more efficient and to improve my workflow. Because in this job, one thing that I had to do over and over and over was to divide the scene into different render layers. So the background will be one layer, and then the same thing for the foreground, and then the same thing for the characters. And then I'll have to apply some shaders to grab the shadow so then I can do some comp later. And it wasn't something too difficult to do, it was just tedious and time consuming. And in a production where I had to do multiple shots per day, this was taking a very good amount of my time. So obviously I didn't use C at that time, but I found a scripting language in Maya which is called Mel. And that allowed me to create a couple of tools that will very easily save me hours of setting up these scenes. And since then, this has been my approach. Every time I move into a new software, I make also the effort to learn the scripting language. For example, if you work with 3ds Max, you're going to work with MaxScript. Obviously, if you're working with Houdini, well, you know about Vex. But it gets to a point that when you need to do something a little bit more complex, the scripting language, they aren't enough. You need something else. And this is where Python comes in and can be your friend. So by now, you may be thinking, that's a really nice story, but I'm still not entirely sure if this workshop is for me, because you probably heard that programming is difficult, you need to be super smart to be able to do it, or you know some coding, but you don't know where to start with Python for Houdini. Or perhaps, as someone told me recently, Houdini is already very technical. I'm learning Vex, and now you're telling me I have also learned Python. But let me tell you that when I was approached by Rebel Way to cover this topic, my idea from the start was to create something precisely for artists like you and me. I wanted something that is going to give you the resources, the tools, and the knowledge so you can start creating your own tools and level up your skills from week one. So what are we going to do is we're going to focus on practical tools. These tools are based on real production scenarios, and they are going to show you that coding with Python not only is something easy to do, but it's also very fun to do. And that's my idea, is to create a workshop that show you how easy and practical and fun is to start using Python in Houdini and creating your own tools. Let me tell you, there is nothing more mind-blowing than when you create your first tool and it works, it does what you want, and you just feel unstoppable. It's just like, this is the start pointing for me. Now, I wouldn't say that programming is something difficult to do, because in simple terms, programming is telling the computer how to perform a task. You provide the sequence of steps, the computer follows those steps, and performs the task that you want to do. And this can be as simple as save this Houdini file, if there is a version, check the version and version up. Or it can be something more complex where you're starting to create tools to create an entire pipeline. But the idea of programming is that you pick up a problem, you divide it in smaller steps, and then you provide those steps to computer to solve it. Now, Python is an ideal starting language because it's very user-friendly, in particular when you compare with something like C++ or C# or Java. It is an interpreted language, so it means you can run your code immediately, and it makes it super easy for us to just test things and just to prototype. Also, Python is widely supported by other tools. So Houdini, Substance, Painter, Substance Designer, Maya, Mari, all these tools that we have in our industry, they support the use of Python. So that means that what you learn on this workshop, with a little bit of help and documentation, you can also apply the same principles and idea with other softwares. If you are new to coding and if you're new to Python, then my recommendation for this workshop is for you to take the time you need to practice and have patience. Some of these concepts, they are going to be new to you. I am doing my best to use simple examples to explain these core concepts, but still, you may need some time to fully understand how they work. The other thing you're going to need is consistency, and I think this is one of the key aspects if you want to be successful taking this workshop. I believe personally that it's way better for you to spend each day, even if it's just half an hour, to stop what you're doing, to focus on a workshop, learn, practice, and applying these lessons, than perhaps saving, let's say, a Saturday afternoon where you're going to sit down for 5 hours and you try to cover everything that we did for that workshop. A little bit each day is going to help you to reinforce what you're going to learn, and I think it's going to be way beneficial if you just want to spend a large chunk of time focus on a workshop. Also, if you have no prior experience with programming, our first 2 weeks we're going to focus on core Python concepts through the creation of simple but useful tools. The idea behind these tools is to introduce you the basics. It's going to make it easy to follow along and apply what you learn immediately. I want from week one for you to start coding, get your hands dirty, and getting excited of what you can accomplish with this workshop. And I want to use examples that teach Python because I know that it can be very abstract and boring learning about, let's say, models or classes or strings or lists without a practical example. It doesn't click initially. So having examples is going to help you to understand all of these topics. If you already know Python, you'll still find value on this workshop because after we cover the Python fundamentals on the first 2 weeks, we're going to fully immerse into the Houdini model and explore what we can accomplish in all the contexts. Each week, we're going to build practical tools. These tools are inspired by real-world production scenarios, so you're going to find them useful if, for example, you work on a studio. And we're going to touch on almost every single thing that you can do with the Houdini model. Working with subs, working with lobs, creating HDAs, creating parameters, working with shelf tools, building user interface with a Qt designer, incorporating and use Python models, working with JSON files, Python states, the template groups, package, models, and so on. So there's a lot of things we're going to cover. To try to accommodate the different experience levels, what I did was I created shorter videos that cover the fundamental Python concepts. So if you're already comfortable with Python, then feel free to skip those sections. However, if you are new to programming, then I recommend using these videos to reinforce your understanding, particularly as we progress to more complex Houdini Python applications. While we won't cover every aspect of Python and the Houdini Python model, I will provide resources for further study. The primary goal of this workshop is to give you a solid foundation so you can start building your own tools and also access this workshop as an ongoing reference to reinforce your learning. And once again, welcome to this workshop. I'm very excited about the opportunity to be your guide and to show you the cool stuff that you can do with Python in Houdini. If something doesn't make sense, my role here is also to be your guide. So there is no such thing as stupid questions. Reach out, ask me the questions you have. Don't be afraid to make questions because on these first 2 weeks, you need to create some good and solid foundations in order to build on top of that. So I hope you are as excited as I am, and let's start this workshop. Hello everyone, and welcome to this class where we are going to focus on a couple of things that are going to make our life a little bit easier when coding with Python for Houdini. Now, the first thing we're going to do is creating a new interface or a new desktop for Houdini. Just a couple of things are going to help us to be more efficient on how we program or code with Python in Houdini. Then we are going to install Visual Studio Code, which is a code editor, and setting up that code editor for us to be able to work with the Houdini model inside the Visual Studio Code. So what you have, for example, with the Python source editor, where you start autocomplete, giving suggestions, we are going to have the same thing in Visual Studio Code. And then after we have all of that set up, I'm going to show you how you can create, in a very simple way, a package for us to be able to use an external editor inside Houdini. So in Houdini, and I'll see that in a second, you can automatically launch Visual Studio Code, for example, to edit the code you already have inside Houdini. So it becomes easier to do that automatically instead to manually open Visual Studio Code and copy the code you already have in Houdini and then paste in the Visual Studio Code and go back and forth that way. So in terms of the interface, I have here Houdini open. The version that I'm using is the 20.5370. I would not recommend for this workshop to go to Houdini 19.5 because some things are a little bit different. Also, the way the Houdini object model works is slightly different, so it can be confusing. So anything from Houdini 20 can be Houdini 20 forwards, it's completely fine. Now, how are we going to set up the interface in a way it's going to be helpful? Well, the first thing I will do is to split the paint top and bottom. And here we are going to need a Python shell. Okay, so the Python shell is extremely useful for us to get feedback on what's happening inside Houdini. So we can see any errors we may get when running the code. We're going to get the print information on the Python shell. It's always a good idea to have the Python shell open, in particular because if you are testing some coding and if you don't have the Python shell open, if there is any information that goes to the Python shell, you don't see it if it's not open. And it's quite useful to have that information, particularly when you are trying to fix any errors or bugs. So this is one thing that's going to be quite useful. And then here, what I'm going to do is divide again. And this time I'm going to split left and right. And here, what I'm going to look for is the geometry spreadsheet. Okay, so this is going to be quite useful for us to have access to things like attributes, other kind of information. It's going to be quite practical. Now, here on the right side, there's two things we are going to use then later, but it's a good idea just to have them here ready for use. And is these two inspectors. We're going to see the viewer state browser, and then we're going to click and create another one for inspectors, and we're going to select the viewer handle browser. This is going to give us information later when we start to working with the viewer states and see how we can control, in particular when working with Houdini digital assets. So that's basically it. The other thing that you'll have to do manually every single time, because unfortunately you cannot open, as far as I'm aware, you cannot open the Python source editor as a single pane. So this is more or less the interface we're going to use. Like I said, the Python source editor have to be open every single time. But now what you can do is you can save the current desktop as, and then you can give a name, just going to give like coding 2, and save it. Okay, so we have this confirmation. So now we have everything we need to start coding. So that's the first step. Now, the other thing we want to do is to install a code editor. These tools are particularly useful because they're going to help us when we are writing longer code. Most of the times when I'm doing something very short, I use the Python source editor. It's perfectly fine to do something, I would say up to 50 to 100 lines of code. But more than that, it becomes quite difficult to keep track of what you're doing, and you have to go back and forwards here in the Python source editor. So it's a great idea when we're doing something a little bit more complex to use something. In my case, I like to use the Visual Studio Code. If I open the website, and by the way, one thing I want to highlight is that when you search for Visual Studio Code, this is what you need to type, because there is also a Visual Studio, and this is not what we want. We want the Visual Studio Code, which is free to use, and then you have the option for Windows, for Linux, and for Mac. So if you are, a different machine like Linux or Mac, you can still use it. And the cool thing is also you can sync the settings you have between different machines. This is particularly useful for several reasons. Mostly because when you are writing code, the computer is going to do whatever you tell the computer to do. So if the computer is not doing what you want, the issue most of the times it's not the computer, it's you. And that is perfectly normal. As humans, we make mistakes, and sometimes we are writing something so simple as a variable name, and the name is wrong. And these type of mistakes down the line, it can cause some issues. First of all, the program is not going to work. But then also it's going to take time because it's not working, why it's not working, and you have back and forth trying to understand what's happening and the codes, and then 10, 15 minutes later, you just realize, oh, the variable name is completely wrong. I can't believe I just wasted half an hour trying to find something for so simple as this. And these type of code editors, they help you quite a lot because they find those mistakes and they tell you like, hey, this is not right. This is not being used. Whatever you're writing, it's not, except for example, for Python. So it helps you to avoid those basic mistakes, but they happen even with people with many years programming. They'll still make these mistakes, and it's a great tool to use. So go ahead, install the Visual Studio Code, because then what I'm going to show you is very specific for this. I don't know necessarily how to set up, for example, PyCharm is another option to work with auto-completion for Houdini object model. So this is going to be very specific for this software. It's free to use and is constantly being updated. So as you can see here, there is already a new version available with fixes for October. So when you launch the Visual Studio Code, you may have something like this. The interface is very simple. Here is where you are going to explore. You're going to open the files. With that thing in mind, instead of opening files, my suggestion will be for you to open folders where inside you have your code, for several reasons. First of all, because you can save things more easily, you can jump between different files easily, so it's a better option to do that. Then there is more things we're not necessarily going to use, but then we have the extensions. The extensions are going to bring more functionalities to the Visual Studio Codes. For example, something we have to do is definitely to install Python and Pylance and a couple of more extensions for us to be able to work with Python. Now, before you obviously just spend some time to explore how it works, I think you'll see something like this here, like get started with Visual Studio Codes, learn the basics and start coding, just to have an idea and a feel how things work. But something I'm going to recommend you to do is to create a profile specifically for Houdini. So on the bottom left, you're going to see a gear as an icon, and then when you click it, you can come to this option here to create a profile. So you can see I already have profiles, and then I'm going to delete this one just to exemplify what you need to do. So delete. So I have one called Houdini. And then it's very simple to create a profile. So for example, if we create a new profile, you just give a name. So in this case, like Python, for example. And then what you want to have: settings, none. Keyboard shortcuts, you can leave it default or give it none. It's not a big difference. And then extensions, leave it to none. And once you select a different icon for this one, you can select, for example, this. You can click create, and that's it. You have your profile. So now, again, if I go to the bottom left, you can see that I already had selected and active the Houdini profile, but here you can select a different profile if you want to. This is particularly useful if you are working with different language, for example, and then you don't want things to, different language being together with different extensions. It can be difficult to manage and to organize. So my suggestion would be just to leave the default as it is, create one for Houdini. I'm going to just going to leave the Python open so we can go through the process. So now if I go here to extensions, you'll see that we don't have anything installed. You probably don't have anything installed. And the cool thing is if you click here like a new, so let me show you again. So right click, new text file. If you click on select a language and then type to work with Python, there is a pop-up window and say, hey, do you want to install a recommended Python extension for Microsoft for Python language? And then show the recommendations. And you'll see it gives you a couple of recommendation things you should install. So the things you need to install is, first of all, install Python. Then you also need to install this one called Pylance. And then recommend also to use the Python debugger. Okay, so those three are essential for you to work with Python. inside Visual Studio Code. Now, if I go back to my Houdini um, profile, I'm just going to show the ones that I already have installed, just to exemplify a couple more things that will be quite useful for you. So we have Pylance, we have Python, we have the Python debugger, and then the other ones I would recommend you to install is the PySide 2 for Visual Studio Code. This is going to be very useful for you once we start doing some user interface with PySide 2. Then the other one that you all can also install is the Vex. So you can do some Vex coding inside Visual Studio Code. And as you can see here, this is going to give you access to the syntax, to some function descriptions with attributes, make it easier to do some of the coding here instead of doing inside Houdini. Then the other one, which is quite useful, is the code runner. What this does is gives you the ability of just running specific lines in the code without having to run the entire code. So if you don't have these, you'll have to run the entire code. But sometimes we just want to test a specific section of the code. And then what you can do is you can select and you can say just run this section and it'll do it for you. Now, one thing that I want to touch is the use of AI when coding. And you'll see that I have one here installed, which is called Cody. It's an AI coding assistant with autocomplete and chat. This is a very useful tool for the reason, as you can see here, when you are starting to type, it gives you suggestions based on what your code is. There are points where you are writing the same thing. For example, you're writing a if statement to check if certain type of textures exist, and then you need to check for different type of textures. And instead of having to write that manually, for example, this tool is smart enough to see what you did once, and then ask you, do you want to do this for the rest of the code? This is a very useful tool. I would say if you are learning how to code, if you are learning Python, I would not recommend you to use AI tools for the reason that you're not going to be learning. You're going to be copying code from ChatGPT, whatever AI tool you're going to use, and then just paste it, and it works, maybe. You don't necessarily know why, but it works, but you're not learning. And then the danger is you don't know how to fix it because you don't understand what is there. So that's my recommendation, to be honest. I avoid using AI to code because first of all, I don't trust too much on the code because it is giving you information that is wrong. And that's a danger of using these kind of tools while you're learning because you don't understand what's happening. Some information sometimes is wrong. Other times, it may not be the most efficient way to work. It's up to you, but I would recommend you to, for now, if you're learning, to try to avoid these type of tools, precisely because they are not necessarily going to help you to get good foundations, to understand the core concepts. And you may be faster initially, you may get things done initially, but then it's not going to pay off down the line because you don't have the structure, you don't have the foundation for you to be able to do something this alone. And that's the thing. If you get to a place where you don't have access to this tool, you don't know how to code because you rely on those tools. So that's my view on using AI to code. I have nothing against people who use it. I'm just saying if you are new, just be careful. So that's the main thing. Okay, so this is the extensions that I recommend. So Pylance, Python, Vex, CodeRunner, PySide 2, and the Python debugger. And then one thing that we need to do is to bring the Houdini object model into Visual Studio Code so we have access to those methods and also have access to some help to be able to do coding inside Visual Studio Code. So let me show you what I mean. If I go back to my Houdini, one thing is quite useful is that you don't need to be checking the documentation all the time because most of the times you're going to have the same information inside Houdini. So for example, I like to use this as an example. If I start with the U model, and then you see how when you click on the dot on the period, you're going to get a list of things that are available. And then once I start to write, this is the one I want using the UI. And then when I click again the dot, this is going to give me a list of things that are available. Right? And if I click to something like display message, and then I open the parentheses, you see that I am going to get like a help section to use this method. And this is extremely useful for you not having to go back and forward with the documentation in the Houdini website. Is everything is inside here for you to use. So we want to have this, but inside Visual Studio Code. Because if I go back to Visual Studio Code, if I go here, create a new text, and then I'll say I want to work with Python. For a start, for example, when I do import, and if I say import u, and then I do like u.ui, you see that it's not giving me the same information. It kind of already is telling me here, for example, you see this wiggle line, yellow, and say, I don't know what this who model is. And then once I start writing, it doesn't know what is next. I would expect having like a list of the different methods that I can use, but I don't have that. So what do you need to do to get access to that? Well, let's go back to Houdini. And then here in the object context, I'm going to drop a geometry node. And inside the geometry node, I'm going to drop a Python node. Okay, so this Python node, and if I go here, we'll see we have some code inside. And then instead of me just telling you what the code to write, I'm going to provide this as a snippet of code for you just to copy and paste. Also going to provide the website where you can find more information. Because it just explains what's happening here. Also adds an extra step which it's useful, but I don't think is essential for us. So this is very practical. This is very useful. And I made a mistake actually here, which is good to show you that once you click outside, we are going to get a bunch of code here. But before we do that, because you see that a line finish here and then has to go to the next line, and we don't want that, because otherwise we'll have to make adjustments manually. So what I'm going to do is just giving a couple of more lines and do it again. Just click outside, and okay, this is what I want. So this is going to give me all the information that I need to provide to Visual Studio Code to have access to the auto completion and also to the help section that we're going to use. So if you start with this curly bracket here, and then press the shift key and then click to the last curly bracket, and then you click on copy, we are going back to Visual Studio Code. And now if we click again on our on the bottom left where you should have the icon for your profile, if we go to settings and then we scroll down in the extensions, right? And if we go to Python, there is this section here for the autocomplete extra paths, and you have the edit in settings.json. So when you click this you have this text here, but what you can do is just delete everything, paste what you have, right? And then save it. And now if I close everything actually, and if I click don't save, if I click a new text file, select Python, and now if I start by writing import the Houdini model, in a sense what the Houdini model is, and then again going back to my example, so if I bring the Houdini model, now I'm getting a lot of like the options that I have available. So what do you want to do? Well, I want to go and check the UI. Okay, so if you press the tab key, you're going to get that. So for example, U, and then press tab key is going to autocomplete, and then I get dot, and now what I want is the display. So if I do the same thing, display, just select display message, again, the tab key is going to autocomplete, and then when I open the parentheses, it's going to give me like all the information that you find with the Python source editor or where you find in the Houdini documentation. This is very useful because, like I mentioned before, you don't have to go back and forth with the documentation, and you can get all the information here. So this is how you set up the Visual Studio Code. There isn't much more you need to do. And now we're going to do something for us to be able to use Visual Studio Code to every time we want to edit the code inside Houdini. And what I mean by that is if I close the Visual Studio Code, and if I go here, for example, or even here with a Python sub, if you press Control E, this is going to open a new window. And then on this window, which is very similar to the one we have here with the Python source editor, you see that the last button that we have is this one, which is Edit Text with External Editor. Now, if you click here, this is going to open the notepad, and this is not something that's quite useful for us. So what we want to do is every time we press the Control E again, or just click on this button here to open the external editor, we want to use the Visual Studio Code. So one way we can do that is by setting up a variable, and that variable is going to point where the Visual Studio Code is. So if you go to Help and we go to Contents, bring the window back here. Here I'm going to search for variables, and I'm going to environment variables. We have one which is called editor, and here we see that Houdini will use this variable to determine which external graphical editor to invoke when editing text. And you can use the variable editor, or you can also use the visual. So there's two options you have here. Now, for us to set up variables, and you can actually click here, the best way to do this is by creating a package. So where can you find and set up that package? If I close this window, and if I go here to Help, and if I go to About with Houdini, and if you click on Show Details, what we are looking for is down here, close to the end, we are going to check the Houdini User Pref dir. So this is where you're going to save your preference. So it's usually inside the documents and the Houdini, whatever version you're working on. And if I go to that folder and I close this window here, right, let me bring back the folder again. This is what you should have. And before, we would set up these kind of variables using the Houdini environment, but this is something, even if you open the file, tells you like the best way to do that is by using the package. So open the package, and you probably just have, well, maybe you just have the OCIO. I have the Arnold installed, that's why I have this one here. But then you can create a new one, and the way you can do that, for example, in Windows, is by a new text, and we can give it whatever name you want. So for example, we can give editor, and then instead of using txt, we want to use the extension JSON. I'll say change, yes. I have one called visual, that's what I'm going to use, and I'm going to open that one, and I'm going to do it with the Node++. So it's going to be empty, and what we need to write inside is just a couple of lines. We're going to start with the curly brackets, so we're going to open and close with curly brackets. So open, and then give it some space, close with curly brackets, and then inside we want to specify what's the variable that we want to work with. So we want to do it with the environment, and then we put a colon on front of it, and now we're going to a new line, and we're using now the square brackets. So open with the square brackets, and then go just another line, close with the square brackets, and inside here we're going to again open with the curly brackets, and then we'll close with the curly brackets. I'm going to give indentation here. You can do that with a tab key, so do something like this. Yep. And now we are going to open with double quotes and say visual, and then with close with double quotes. You can write visual or you can write editor. It doesn't really matter. You can use both of them. So I'm going to use visual, and then put a colon here. And now what we need to put in front of this is the path to the Visual Studio Code. So if you go to your machine, and I'm going to show you that in a second. So if you go to something like this, where you have a list of the software that's installed on your machine, and then if I click here on Visual Studio Codes, I have the shortcut to the application. Now if I right click and then I select more options and I select properties, here in Target, I'm going to get the Windows path to the software. So if I click Control A to select all, Control C to copy, then all I have to do is come here and then paste. Now, one thing you have to do if you're working in Windows is instead of using just one backslash, you actually have to add two. Otherwise, this is not going to work. So in all of them, I'm just going to add another backslash. Or if you want to do, instead of just adding two backslash, you can just delete the backslash and use a forward slash. This will be exactly the same thing. Just for the sake of consistency, I'm going to use all the backslashes. And now this is all you have to do. I'm going to save. And now what I'm going to do is I'm going to restart Houdini. So now that I have Houdini restarted, I can come here, click on New tab. And then if I go to Inspectors, I'm going to select the package browser. And you'll see that you probably have something like this. You have one called Visual. It has the check, green check, and it has the variable inside Visual, which is going to point into this. So now what you can do is, for example, if I go to Object Modes, and if I, again, do like a geometry node, and inside I'm going to use a Python. Now, if I press Control E and then Control E again, I have Visual Studio being open in order for me to write the codes inside. So for example, if I say print geo, and if I save, then you have to close Visual Studio Codes. Now the code is going to be updated here. And you can do this in several places, right? So for example, if you open the Python source editor, you can do the same thing here. So Control E is going to open an external browser. Again, import the U model, and then yeah, we can do the same example. Ut.display message, and then just open and close, save, close Visual Studio Codes, and there you go, you have it. So in conclusion, what we learned on this video was, first of all, how to set up the Houdini desktop to work with Python inside Houdini, having the Python shell, having some extra tabs. We're going to see that later, along with the geometry spreadsheet, which is always quite useful. Remember that you have to open the Python source editor manually, unfortunately. Then we install Visual Studio Code. We also added some settings for us to be able to have access to the methods to work with the Houdini object model, but also, as we see here when we do the parentheses, having access to this help section, which is quite useful for us, avoiding having to go back and forth with the Houdini documentation and have everything inside one place. And then finally, we created a package called Visual, and inside that package, we are pointing to an external code editor. So every time we press Control E, this is going to open Visual Studio Code. We can do our code inside here, and then once we save and close, we have the code back inside Houdini ready to go. And with all this done, I think we're ready to start this workshop. Hello and welcome to this lesson where we're going to cover the Houdini object model, which is the way that we interact with Houdini using Python. But before I jump into that topic, I just want to very briefly to share with you two resources that I think are going to be extremely useful, in particular if you are learning Python for the first time. The two resources are these two websites. The first one is the w3schools.com, and as you can see from the front page, this is a website dedicated just to coding. And if you select Python, one of the things that I like about this website is the fact that everything is explained in super simple terms. You can see here for the variables, there's not a lot of text, just a couple of examples, just showing how you can create variables. If I go to Booleans, for example, you have exactly the same thing. And then another thing that I like about this website is the fact that sometimes you may not be in front of a computer that has Python installed, but you can use their Python server just to test some code. Now, obviously, this is not as efficient as running the code on your machine. You'll see if I change the value from 200 to 1 and if I click run, there is a delay in getting a response. Still, is a good way for you to do a couple of tests if you don't have a computer and if you don't have access with a computer with Python. If I go back to the website again, you'll see that there is a lot of things that we're not going to cover because they are not relevant for the workshop. If you want to learn machine learning, MySQL, MongoDB, there's a lot of things you can double check here that are going to extend your knowledge about Python. But then if you want something, let's say with a little bit more meat, with more substance, then I recommend you to check this website, realpython.com. And this website is great because it goes in more into depth in some of these topics. So for example, if you go to variables, and if I click here, we have a page for usage and best practice. And you can see the difference comparing with level 3 schools because you have way more text, more explanations, more examples. So it's something that goes into more detail than level 3 schools. But it's two great resources. One you can use as a quick reference just to check how you can use, for example, creating strings. And then if you need more detail, then you can come to Real Python. So these are the two websites that I wanted to highlight. Now back to Houdini and back to the Houdini object model. Now, what exactly is the Houdini object model? Well, let's go to help and go here to contents. And I'm going to drag the window to this side. And if we scroll down, we'll get to this section called reference. And you'll see it here something which is called APIs. Now, API stands for Application Programming Interface. And basically, an API is something that enables us to put requests and receive responses from software. Let's compare, for example, when you go to a restaurant and you want a specific dish on a menu. You don't go into the kitchen, you grab the ingredients, or you're going to tell the cooker how to do the dish. You put your request to the person serving you. That person goes into the kitchen, it puts a request for you, and then it gets back to your food. And the same thing happens with the API. Actually, just to expand a little bit more this example, sometimes the waiter, the person is serving you, it will even ask you for parameters, arguments. Do you have any allergies? Is there anything you want to add? Is there anything you want to remove? And the same thing we can do with the API. We can give a set of instructions and then we get the information back. So the API is how we're going to interact with Houdini. And if you click here, you'll see there is a list of APIs that we can use. But the one we want is the HOM, or the Houdini object model. And this is where we're going to find everything that we need to interact with Houdini using Python. And if I just scroll down, we'll see we have a very, very, very long list of model classes, functions that we can use. And basically, I dare to say that almost everything you do in Houdini, you can do it using Python. So you can work with geometry, you can work with cameras, with the viewport, with materials, almost basically everything. And this is a very powerful tool to have in your toolbox. You are also not just constrained in creating scripts or tools. You can use Python in a lot of places. For example, if I come here and if I drop a geometry node, and inside I drop a Python node, this is another place where you can use Python. Or if you want, you can go back to the geometry nodes, and here, let's say on a translate, we can go to expression and we can add the expression. And instead of using the HScript expression, we can use a Python expression. Or we can come here, we can create a new tool, and you'll see that inside the script, we can change to Python and use Python. And actually, if you select the shortcuts that we have here, the tools we have on the shelves, if you right click and you say edit tool, you'll see that on the script, all you're seeing here is just Python code. So it's a good way for you just to start learning and see how you can use Python. But you can use Python in many locations. That's why it's quite important to understand how to work with this Houdini object model. Because here we're going to find everything that we need. Now, One thing we have to understand is that Houdini is designed around nodes. We know that we can work in subs, we can work in lops, we can work in dops, and so on. Now, this node, for example, as an object, it contains data, it can perform actions, and this makes it easier for us to structure and design our code. And the way we have access to that data and actions is by using the methods or the functions that we find here. Now, I think the best way for you to understand how to work with this documentation is by actually showing an example. And that's exactly what we're going to do. So I'm going to open in the Windows the Python source editor, and then just going to have my Python shell open and trying to put the Houdini documentation here. And we're going through the process of working with this Houdini object model and also trying to explain a couple of the concepts that you have to keep in mind that are going to help you to code with Python inside Houdini. Now, the first thing we have to keep in mind is that for us to create objects like this node, we need to work with something that's called classes. Now, classes are like blueprints or recipes to create objects. And when you create an object like this geometry node, using the class, we say this object is an instance of a particular class. The question is, how do you know what class was used to create this node? Well, we have to use something called the type function. This is going to give us information of the class that was used to create this node, and then that way we understand the methods that we can use to control this node. So what I'm going to do, I am going to start by just deleting this geometry node. So I'm going to start by importing the Houdini model. And I know it's not a requirement to do this. I think it's a good practice because sometimes when you are testing your code, there's something that breaks the code, and there will be situations where Houdini will come back to you and say, I have no idea what this Houdini model is. I think is a bug. And you can solve that by just import the Houdini model. So it's a quick fix. Now I'm going to create a variable. I'm going to call it obj, and then I'm going to use a function in Houdini that is going to return an object. And the function is the who.node. And what I need to provide is a path for that node. And I'm going to do that by open with a single quotation mark, /obj, and then close the single quotation mark, parenthesis, and that's it. And this is making reference to this object context. So for example, if you want to work in stage, all I have to do is instead of the obj, just replace with stage, and it gives you the same thing. Now, if I create a print, and then I'll say type, and I want to check what type is this object variable, and I click apply, you'll see that this is giving me information that the class used to work in this object is going to be op node. So what is this op node? Well, we can come here to the search and say, give me the op node, and you'll see this is a class. And here it gives you the information. This is a base class for all the nodes in Houdini, the objects, subs, cops, or etc. So this is what is going to provide you some methods in order for you to create, to remove, to evaluate parameters, and so on. Now, I want to create a geometry node inside this object context. So how can I do that? Well, if I come here to filter, there is actually a function called create node. And this is a great example of something that happens in Python and it happens in Houdini, which is that some classes, they are going to inherit methods from other classes. So just to give you an example, this happens in real life. You are an individual, but you have attributes that you inherit from your parents. Some people will say, oh, you have the same smile as your mother, or you have your father's eyes. You are still you, but you have attributes from your parents. And the same thing happens in Houdini, and in particular when you're working with these classes. And the reason why this happens is because it helps to reuse code, and we can build upon existing classes and creating new ones with additional and modified functionalities. So you'll see, if I zoom in, that it's possible to see the inheritance that exists inside these classes. So the hope node is actually a subclass or a child of the who.node class. And the who.node class is also a child of the network movable item, and so on and so on. So we are, in a way, working almost like in layers. And now through the example, you're going to understand how all of these subclasses, they work together. So you'll see that the create node, it doesn't exist inside the hop node, which is the one used for this object level, but is actually a method from a parent class, in this case the who.node. Now, how do you work with this type of documentation? Well, what we're going to see here is a great example of how the documentation in Houdini works, and it gives you all the information that you need. So we have this function or this method called create node, and then there's a couple of arguments, there's a couple of parameters that we need to provide. Some of them, sometimes you don't need to provide anything. So for example, if I just remove this here, you'll see that, for example, this doesn't, you don't need to provide any information. Actually, it returns a list of parameters, in this case as a tuple. Others, they ask just for one argument, one parameter. Let's go back to the create nodes. There you go. You'll see that we have something we need to provide, which is the node type name. But then, do you see everything else when it says like node underscore name equals to none? Then this one is equal to true, this one to true, this one to false. So you don't need to provide this information if you don't want to. If you don't provide the node name, what's going to happen is Houdini is just going to use a default value, and that's how it works. So what we need to provide as default is the node type name. And if I click here on the plus, you'll see that it gives you more information on how it works. And I find this extremely useful because if you are new to the Houdini object model and all this documentation, it becomes quite useful to have access to these explanations. And in particular, if I scroll down, sometimes you are lucky enough to have a snippet of code that shows this in action. So you'll see we are doing something very similar. We have the obj equals to who.node obj. That's exactly what we have there. So if we want to create a geometry node inside this context, then what it tells us to do is to say we need to create the obj dot create node, and then you'll see that we just have to give the node type name. So how do you know that? Well, a quick way to check that is if we drop the node that we want to create, and then if you go to the node info, you'll see that here we have the geometry object, and then between parentheses we have the actually node name as geo. So this is what we need to use to create this geometry node. So what we have to do is doing the single quotation marks. We say geo, and then close the parentheses. And now, if I delete this one and I click apply, we have a geometry node. Now, like I said, we can provide more information. So for example, if I delete this, I can put a comma. And now there's two things that I can do. I can write node underscore name is going to be equal to my geo, and if you do that, it's going to create a geometry node with the name that I gave. Or another way you can do it is just completely remove this, and then after the comma just give the name. And what's going to happen is Houdini understands that after the first comma, what you are providing is a node name. So if you click apply, you are going to get your geometry node called myGeo. So that's how we create our first geometry nodes using Python. Now, to make it easier for us just to now work with this geometry node, what I'm going to do, instead of creating this node every single time, I'm going to create a variable, and I'm going to say this is my geo underscore node. It's going to be equal. And there is a cool thing that you can do in Houdini, which is you can click, you can select the node, and then if you drag and let go, this is going to create the same thing that we have here. It's going to give us the Houdini function to get access to this object, to this geometry node. Now, let's go and just check what class was used to create this geometry node. Is it the op node class? Well, let's check. If I just drop it here, give a couple of lines, and I'll say apply, you'll see that to create this geometry node, we actually use the object node class. Now the object node class, if you scroll down, you'll see that it's a child of this op node. So if I select this one here, now I have access to all the methods that I need to be able to control, to manipulate, to do everything I want with this geometry node. So one thing that I can do, for example, here is just to check the origin for this node. So how can we do that? So we know that this geo underscore node has this object. Then so what we have to do is we're going to remove this type, and inside again copy the geo node, and then in front of it what I'm going to do is just type origin and open and close the parentheses. And now you'll see that if I click apply, it's going to give me this vector tree, right? It's related to this translate value. So if I change this to something like 153, and if I run again, it's just going to give me that information. And that's how you work with these methods. So it's a good idea to go through these classes, see what's available, and this will help you to understand the things you can do with these type of methods. For example, here we have an option just to check if the display flag set is on. So for example, if I just copy this, and then if I go here and I place it, what I'm going to get is a boolean. So if I click apply, it's going to say it's true. If I remove it, click apply, it's just going to say it's false. So then what you can do is if it is off, you can set display flag, and you'll see that in this case, we actually have to provide information. So either is on or is off. So inside what I need to provide is a boolean, so I'm going to say it's true. So you'll see this is off, and then I'll click apply. So now it's on, or if I want to turn it off, I can say false, and then it'll do precisely that. So it's a good example of the things you can do. Now let's make this a little bit more complex, not too complex, but a little bit more. Just going to make this on again. And let's say that inside these nodes, I want to create a cube, a box. So what do I have to do? Well, we know that before we use the obj.create node. So we have this geo underscore node, and we want to create inside the box node. So here what I'm going to do is a geo underscore nodes, and then I'm going to say create node. And again, remember what we have to provide. We have to provide the node type name. And one thing that I like in Houdini is that everything is very intuitive. And most of the times, using common sense, you can get to things without even checking. Now we want to create a box. What do you think would be the node type name to create a box? And you are right, it's just box. So if I do this, and if I, for now, just don't print anything, just print hello, and I click apply, you'll see that inside, now we have a box. Now same question, what class did we use to create this box? Well, there is one way to know. Making this a variable, box underscore geo, is going to be equal to geo.node create node. Just going to delete this, and then inside here, I'm going to remove this information, type, open parentheses, copy the variable inside, close parentheses, and now just pay attention here, because we're going to get that information, which is a subnode. Now, there is a difference here, and this is something I want to highlight, is that technically, inside Houdini, this box is a child of this geometry node. Wherever this geometry node goes, this box goes. That's it. But this is not what's happening with Python, because if you see, the class that was used to create this box node was a subnode. Now, if you see it here on the documentation, on the object nodes, we don't have any child class called subnode. Actually, the subnode is a child class from the op node. So the object node and the subnode, they are not related. You're not going to find methods from the object node inside the subnode. And this is something you'll have to keep in mind, because you would say, well, I know that, for example, to check the position for the geometry node, I used something which was the origin method. So maybe something similar happens with this box. So you can try it, like go here and I'll say dot origin, open and close parentheses. And when I click apply, we're going to get an attribute error and say, hey, subnode doesn't have any method called origin. So I have no idea what this is. So this is the difference sometimes you have, and this is why it's important to use the type function just to check what class was used to create the object, and that way you know if you're working with the correct class. So if we go back to the subnodes, and one thing that I'm going to do is, again, I'm going to remove this create node so we don't have to be creating and deleting every single time. And I'm going to copy the value here. And now inside the subnode, you'll see the same thing. We have access to multiple methods. We have access to things we're going to provide as just values. Other things we have to provide the value just to get the return. But one thing also to keep in mind, and I want to highlight that using this geometry function, is that sometimes you are going to get back strings, or you're going to get back a list, or you're going to get back like a float value, but sometimes you're going to get back a class as a value. And what I mean by that is that, for example, if I change this to box underscore node, let's say, it's going to be equal to box geo. And in this case, what I want to use is this geometry method. And this geometry method, it tells you, it returns the geometry computed by the subnodes. So it's going to return the geometry you need, like the points, the primitives, all the information used to create this box. So what you need to do is the geometry. And then if I check the type for this variable, you'll see that we are no longer inside the sub class, we are in the geometry class. So to be able to control the points or everything related with geometry, we actually need to dive into this geometry class. And inside this geometry class is where we're going to have access to everything that we need about point, group, attributes. If you scroll down, you'll see all of those methods that are available for you. Now, one thing that I want to highlight is the fact that if I scroll until the end, you'll see that this class, it's not related with any of the classes that we're working so far. So it's not related, for example, with the subnode class or with the object node class. This is a class which is independent, and you're going to find this quite a lot. For example, if we want to work with points, and if I go here to filter, and if I type points, you'll see that the points are going to give me another class, which is dot point. So to get access to that, what I'm going to do is create a box variable called box pt for points, and inside is going to be box node dot points. And if I would print this, you'll see what's going to happen. Is that I'm going to have access to all the points that actually you see here in the geometry spreadsheet. And if you want to have access, for example, to the position, then what you need to do is to dive into this point class. And here we are going to find precisely the same thing we saw in the geometry class. The point class is independent from everything else. So we just have a couple of methods. But let's say if we want to have access to the position, now what we need to do is we already have the variable that represents this object. So what we can do is we have to select a point. So let's select the point 1 using the square brackets, and then I'm going to put this position. So if I do this position, this is going to give me the same value that I have here. If you try to use this position in this geometry class, this wouldn't work. So for example, if I would do something like box point and then put position, this is going to give me an error saying that this object doesn't have an attribute called position. And it's right, because we are not working with the correct class. We need to work with a box underscore pt that represents this object. Now remember that everything inside Houdini is represented by an object. And here's what telling us is that this object, it was created with the geometry class. It doesn't have any method called position. And that's why we need to select the box underscore pt. And then when we replace it, and then when we give the point number and you click apply, it's when you're going to get the correct value. You can use methods not only to check values, you can also use to set values. And for that, we can use another class. Yeah, you're right. We're going to use a class called parm here. And this class, it's going to allow us to set some values. Let's say that we want to change, for example, the size or just the scale for this box to something so much bigger. So you can see there in the background. We move this here so you can actually see it in action. Yeah, there you go. So let's say that we want to set. So what we need to do first is we need to work with this box object, right? So what I'm going to do is picking up this box geo, and then I'm going to remove this print. And what I'm going to do in front of this, I'm going to put the parm class. And in the parm class, I can check what's the value for this, let's say, to the uniform scale. Now, one way to get the parm of the parameter is if you over the mouse in the names of these, like size, center, rotate, uniform, scale, you'll see that we'll get a pop-up window and tell you like the parameter for this is called scale. So that's what we're going to do. And if you open with single quotations and if you type scale and then you close, you can do something which is called eval. So just get me the value for this. And we're going to print this value just to see what is the value that currently we have there. So if I click apply, you'll see that the value is 0.25. That's exactly what we have there. So what if we want to set the value? And you are correct, we are going to use a method called set here, see? And what we need to provide is a value. So what I'm going to do is instead of working with a print, I'm going to remove the eval, and instead of that I'm going to use set, and let's use whatever value we want to use. So let's say 2.5 for example. And now when I click apply, you'll see that we change the scale just using this parm class. Now, this is a very simple example just to give you an introduction to the Houdini object model. So let's recap just to see what we learned so far. Now, to create objects like this box, we need to use classes because classes are like blueprints that gives the information for us to be able to create, for example, this box. When you create an object using a class, you say that that object, like this box, is an instance of that class. Then we saw that we can use the function type, this one here, so type, and in between the parentheses you can put your object, and this is going to tell you which class was used to create this object. And this is the information that you need because that's going to give you access to all the methods that you need in order to manipulate, control, do whatever you want with this box node. One thing we have to keep in mind is that sometimes the class we were using is a child from another class. If we go back to the SOP node class, we'll see here that this class is a child of the op node. And that means that sometimes, not every time, but sometimes we are going to have access, if I scroll down here, we are going to have access to methods that are available on different classes. Not everything is going to be available, just a couple of those methods are going to be available, but it's something worth to keep in mind. And then finally, we saw that, for example, when we had to control the points or when we wanted to change the parameters for this box, we had to use different classes completely independent of this SOP node class. in order to be able to make the changes. But that's more or less how it works. And I think throughout this workshop, this concept of working with the classes and working with the methods and understanding which class you're working on, it's going to be more clear, it's going to be easy to understand. But I hope that this brief and very simple example, it helps to explain the process of working with the Houdini object model so that we can start using Python to interact with Houdini. Hello and welcome to this lesson where we're going to dive into one of the core concepts of working with Python. And in this lesson, we'll see how we can work with something that is called a variable. And a variable is like a container where we can store data. And another thing about variables is that the name we're going to give a variable is going to help us to understand or give some context of what that variable is going to store or what we're supposed to do with that variable. Now, Python doesn't have a command to declare a variable. And what I mean by that is if you're working with, for example, a language called C, and if you want to create a variable that's going to store a whole number, for example, number 10, then you need initially to define the data type you are working with. So in this case, int for integer, and then you give the variable name, number, and then you say that the value is going to be 10. If, for example, you want to create a float, you would do something like this, float, and then you'll say price is going to be equal to 9.99. With Python, we don't need to do this. In Python, the moment we create a variable and we assign a value, we are defining the data type we're working with. So if I want to work with an integer, all I have to do is giving a proper name to my variable, and I'll say it's equal to 10. So a whole number, 10, 11, 100, this is going to tell Python that we are working with an integer. And a quick way for us to check that is by using a function called type. So if I bring the print and inside I say type, open the parentheses and copying the variable name here, closing the parentheses, closing again, you'll see on the Python shell when I click apply that Python is going to tell us we are working with an integer. If you want to create a float, all you have to do is give again a proper name to the variable, and then using the decimal point, it's going to define that you are working with a float. So even if I do 10.0, the fact that we have here the decimal point is going to completely change the data type that we're working with. So copying number float, put it here, click apply, and you'll see that now we're working with a float. One thing that you need to keep in mind is that it's very easy for us to change the data types we're working with. So if, for example, I copy number float, and then I say that this is going to be equal to a string, and to create a string, you can use the single or the double quotes. So this, or you can use the single quotes. Both options are valid. The only thing that you cannot do is starting, for example, with a double quotes and finish with a single quote. This is not possible. But let's say that now we are going to say that the variable is going to store a text, and the text is going to be Houdini. And you'll see that when I click apply, it's going to tell us that we're working with a string. And you can see that by giving a new value to the same variable, we are just basically changing the data type that we're working with. So this is something that you have to be careful, because without realizing, you may be using a variable with the same name and you are using a completely different information inside, and that is going to throw an error, because the way you're preparing your code is to work with a number, with a float or an integer, and suddenly you are providing text as the variable, and that's not what the code is supposed to work with. Another data type that we can work with is called a boolean. So if I create here another variable calling bool underscore val, this could be either true or it can be false. So this is another data type that we can work with, and the variable can store this information so we can use it. By now you saw that every time that I want to assign a value, I'm using the assignment operator, so the equal sign. Now what we can do is, in one single line, we can assign values to multiple variables. To do that, just going to finish this one, and I can create a variable called a, and then b, C, and D. And then I can say this is going to be equal to 10, 10.5, Houdini, and then finally true. You see that we have A, B, C, D. They are separated by a comma. And then I'll say this is going to be equal to the values. And each value is going to be separated by a comma as well. So now if I go to my print function and I'll say I want to print the value for the variable A, you'll see it's going to be 10. And then if I say I want to do the same thing for the variable D, it's going to be true. We can assign values this way, or for example, we can create something that is called a list. A list is a way for us to store data into a sequence. And the way you create a list is by using the square brackets. And inside, if I copy this information and I paste it here, then I can say that A, B, C, and D, it's going to be equal to the values inside this list. And if I give a couple of lines and click apply, you'll see that we are getting the same information. So Python is going to read the variables, is going to read the information inside the list, and is going to assign the correct values. Since we already talked about working with lists, let me introduce you to the other type of information that a variable can store. For example, you can work with a tuple, and a tuple, the way we define is by having a parenthesis, and then inside we can have the same information that we have on a list. They are going to work slightly different. They work with a list. For example, when you define a tuple, that's it. That's the information is going to be stored, and there is no way for us to add more information to what we have here. Comparing with a list, you can add more information if you want to. So we can have another 10, we can have another true value, we can have a false, and so on. With a tuple, that is not possible. Then we also have something which is called a set. And the sets, the way we're going to define is by using curly brackets. And then we can do the same thing that we did with a tuple. We can have this information inside. There is some difference when working with sets. One of the main differences is the fact that what we have here on a list, where we have values that are duplicated, so 10 has another 10 here, and true is duplicated as well. That's not going to happen in a set. You're just going to have unique values inside the set. But you don't have to worry too much about this now. We are going to have a lesson where we go over working with lists, tuple sets, and also working with something called dictionaries. And dictionaries are slightly different from lists, tuples, and sets. We're going to work with the key and value relation. So what that means? Well, first of all, we define a dictionary by using curly brackets. But in the difference to the set is that we start by giving the key that we're working with. So for example, we can say name, and then using the column, we're going to assign a value. So I can say name is Ciro, so that's my name. And then we can create another key, and I can say age, and then I can assign a value. And let's say that it's 30. And then finally, we can assign another key, and I'll say city, and we can give a string and say that is London. So this is how a dictionary works, and a variable can store this information as well. But like I mentioned, we are going to have a lesson that's going to be dedicated to lists, tuple sets, and dictionaries, and help you to understand how you can work with this information. And since we are in the topic of working with data types, what I want to show you is something which is called casting. And let me explain what that is. So if we want, we can do some arithmetic operations working with the values inside these variables. So if I say numInt plus numInt, then we are going to get, oh, give me a second. Yeah, this is causing an error because I have more values inside the list than I have variables. So I'm just going to remove these from here. And then again, if I say number underscore int plus number underscore int, you'll see that we are going to get 20. But let's say that we are going to change this to 10. Technically, what we have here is a number 10. We recognize there is a number 10. But if you're going to provide this to Python, this is going to be seen as a string. It's going to be seen as a text. And then if you do the same thing, you click apply, we are doing something which is called concatenate strings. and you see that the value that we're going to get is 10 and 10, not 20. Why? Well, because for Python, this is not a number, this is a string. So one thing that you can do is called casting. Means you can change the data type they're working with. And what we can do is using a couple of functions that's going to make the conversion for us. We have the int function. So this is going to convert everything inside into an integer. And then also have the float function. So it's going to convert the number into a float. If I, for example, select the int function and I go here and inside I just copy and paste the variable and then I do the same thing. So int, open parenthesis, and then close. You'll see then when I click apply, now we're going to get 20. And the reason why is because we converted this string into an integer. And instead of the integer, if you change for a float for both options, now you're going to get 20.0 because this was converted into a float. You can also convert something into a string. So for example, if I try to do something like this, I'll say this is my number and then plus number float, we are going to get an error. Well, actually, we're not going to get an error because I'm overwriting the value 10 with Houdini. So removing this here, and then now we're going to get an error because it's going to say again that it's not possible to concatenate a string with a float or an integer. So we need to convert this into a string. And one way that you can do that is by using the str for string function. And then inside, you're just going to put the value that we want to convert into a string. And then when you click apply, there you go. This is my number 10.0. There is another way we can do this. It's called the f strings. So what you can do is you can start with an f to define an f string. And then you put the double quotation marks or the single quotation marks, and inside you say this is my number, and then you open with curly brackets, and inside the curly brackets you're going to place your variable, and this way you don't have to cast or convert this float into a string. So when you click apply, you're going to get the same output because we have this conversion happening using the f string. Now let's talk about the names that we're going to give to variables. In terms of names, variables that can have very short names. So you can have something like I did before, A, B, C, D. This is completely fine. You can have something a little bit more descriptive. So like we have here, number underscore int. And in terms of what is valid for working with variables is starting either with a letter or starting with an underscore. You cannot start a variable name with a number. So something like this is not valid. It's called illegal. It's going to give you an error. So in terms of what you can use for the name of a variable, it can be letters, it can be numbers, and you can work with underscores. That's it. That's what you can do. Anything else is going to throw an error. Also, another thing that I wanted to highlight is the fact that this num equal to 26, it's not the same as num equal to 26, and it's not the same as num equal to 26. So what we have here are three different variables, and the reason why is because the variable names are case sensitive. Here I have num written in different ways, and they are different variables. So something to keep in mind as well. So in terms of the what is called legal variable names, you can have something like this. So my name, much better would be my underscore name. You can also have underscore, my underscore name. You can have my name. This is called camel case. And then you can have all capitals, which usually are reserved when you're working with constants, but you can do my name. So all of this is valid. What is not valid is to do something like this, to my underscore name. This is not valid. Not the underscore is invalid, but the fact that we have a number. Doing something like my, and then you have the hyphen, and then name, this is not valid. And something which is definitely not valid is putting a space. So my name is going to give you an error, and it's quite evident because it looks like you have two variables. Now, one thing that we also have to take into consideration is the fact that just because a variable name is legal, it doesn't mean it's a good idea to use it. So one thing that I would say is for you to avoid using single letters as variable numbers. Just a quick example. If you do x is going to be equal to 10, it is a valid name for a variable, but it doesn't really help to understand what x is supposed to be. But if you do something like the number of cameras, it's going to be equal to 10, well, this is much better, because now when you're reading the code, you read the variable name and say number of cameras. Okay, cool, I know what this is. Reading x is not going to help you to understand. So this is what I meant in the beginning when I say that variables help you to understand a little bit the context of what you're supposed to do with them or the information they are going to store. And I would say the only time where you can use a single letter as a variable name is when you're working with a loop and a for loop. A lot of times people are going to do something like this. For example, for x in num underscore cameras, you're going to do something. You're going to print x. This is the only situation where, let's say, it's acceptable to use a single letter as a variable name. Personally, I like to be a little bit more descriptive. So in a situation like this, I'll probably would say for cam in cameras, just because it's easy to understand what this loop is doing. Still on this topic on the names we give to variables, I want to cover how we're going to write those names. And what we've been using so far is what is called the snake case. And snake case means that we write all the words in lowercase, and then if we need to separate words, we are going to use the underscore. So snake case. This is what is used most of the times to write the variable names. I have to be honest, I personally use a lot camel case. I've been using that for many years, but for this workshop, I am making a conscious effort to use snake case for all the names for variables. If you want to use camel case, we use that when I'm defining functions. So if you don't know what camel case is, camel case, again, we start with a word in lowercase, but then the second word is not going to be separate with the underscore, but it's going to have an uppercase, so camel case. And then finally, when we're working with classes, we use what is called Pascal case. And Pascal case, we start each word with the uppercase and no underscores to separate the words. So Pascal case. This is what usually is used when we want to write names for variables, functions, and classes. One thing that I also want to point is that there are specific words that we're not allowed to use because they are called keywords in Python. A couple of examples are the AND word, or the if, or del, or def for defining a function, or for, or from. So all of these are called keywords, and you're not allowed to use these as names for variables. You don't need to memorize this because, as you can see, when we start writing these words, they're going to change the color from white to blue, precisely to highlight the fact that these are what is called keywords. In addition to these, there are also a number of built-in names that cannot and should not be used as variable names. Some of these will include, for example, ABS, and you'll see when I type this is telling me this is a function, and it's going to return the absolute value of the argument. We'll see this when we get into the lessons going to cover working with numbers. But for now, this is just pointing that we are giving a name to a variable that is going to be what is a function. So you should try to avoid that. And then finally, in Python, it is customary to use all uppercase letters for constants. So if you're going to create a constant, you are going to write it this way to define that we are working with a constant. And then finally, I'm going to cover what is called the global and local variables. And for that, I'm going to remove all the code that we have here, just remove all of these. And I'm going to show you the difference between working with global and local variables by creating a function. So I'm going to use the keyword def and then say my function. And then inside my function, I am going to print what we have here. And then if I want to call this function, all I have to do is just copy this, put it here, and then after defining the function, we are going to execute that function. So if I give a couple of more lines here, and I click apply, you'll see that this is going to print, this is my number, and then it's going to pick up this variable that we have here. And the reason why this is working is because everything outside this function is what is called a global variable. It means can be accessed everywhere. However, see what happens when I just going to copy the name for this variable. I put it inside, and then I say that the float is going to be something more interesting. So 5.99. And now when I click apply, you'll see that we are overriding the value with 5.99. And you'll say, well, that's not a big deal because you said that this is going to happen if we, after defining the first value, if we again give the same name to the variable and give a different value, that's going to override the initial value. However, see what happens when after my function, I say that I want to print the value for number float. And see the difference that we're going to get. Click apply, and see that it's going to print this is a number. It's going to be 5.99. And then after that, we're going to print the number underscore float, which you probably think that's going to be the same value, 5.99, but it's actually going to be 10.0. And the reason why is because this variable, although it has the same name that we have here, it's not overwriting the value because it's local to this function. And by local, it means outside this function, we don't have access to the value for the number underscore float. That's why when we print number underscore float, we are grabbing this value and not the 5.99. If we want to make this number float instead of local or global, then all we have to do is using a keyword called global, and then we put the name of the variable that we want to make it global. Let's say we want to promote to global, and now see what happens. A couple more lines, and then I'll click apply. Now we are overwriting the initial value of 10.0 with 5.99 because inside this function I promoted the number underscore float from local to global, and for that reason now we have access to this number underscore float outside this function. This variable stopped being a local variable and it was promoted to a global variable. So that's the difference of working with global and local variables. So in conclusion, in this lesson, we learned that variables are containers that can store data values. We saw that we can store numbers, strings, we can store lists and dictionaries. We also saw the correct way to give names to variables. So they can be short names like X or Y or Z, just single letters, although you should try to avoid that and reserve that type of names for variables that you have in loops, for example, the for loop. And you should strive to use more descriptive names. So when we saw the example of number underscore cameras, is something much better than just using X. It becomes easy to read and to understand what is happening. We also saw that for variables, we use what is called snake case. When we're working with functions, we're going to use camel case, as we see here. And then for classes, we use what is called Pascal case. We also saw the difference of working with global and local variables. And this is something very important to understand, that anything inside a function is not going to be accessed outside that function. It's going to be a local variable. However, anything outside the function is going to be what is called a global variable. And with this, we conclude this lesson and we are ready for the next one. Hello and welcome to this lesson where we're going to dive into one of the core concepts of working with Python. And in this lesson, we will see how we can work with text or collection of text in Python. And when we're working with text in Python, we say we are working with a string. And strings are one of the most commonly used data types in Python. And when we need to make any adjustments to that text, we are going to use something called a method string. These method strings, they allow us to do a lot of things. You can replace text, you can remove text, you can even split the string into multiple substrings. But we'll see more about that later in this lesson. Now, one thing we need to define from the start is that when you define a string, it's going to be immutable. So that means once it's defined, you cannot change later. You can create a new variable with updated version of that string, but the original string, it's not possible to change it. Also, when you're working with a string, you're going to have a length, and for every single character inside that string, you're going to have an index, meaning that each letter is going to have a number associated to that letter. But let's start now initially by seeing how we can define or create a string. So the first thing we have to do is give a proper name to the variable. So my underscore string, and then we have two options. We talked about that on the variables lesson, but I'm going to recap. We have the double quotation marks, and then we also have the single quotation marks. And both options are completely fine. Obviously, as I mentioned previously, you cannot start with a double quotation mark and then finish with a single quotation mark. And also another thing that I wanted to highlight is the fact that there is a document called PEP8, which gives you a couple of guidelines on how to write proper code. Not necessarily code that works, but the style of the code that you're writing. And one of the things that is mentioned is if you are working with, let's say, double quotation marks for all the strings in your code, then you need to use double quotation marks for all the strings in your code. So try to avoid, for example, having a string where it's going to have double quotation marks, and then the next one is going to have a single quotation marks. I'm guilty to do this, but since you are learning Python from scratch, then make a conscious effort of sticking to this rule. It's not going to break your code, it's just in terms of style, it's going to make it look more beautiful. And since we are artists, we want to make things look pretty. So I am going to stick with the single quotation marks, and then inside or between the quotation marks, we write our text. So I can say Houdini, and that's it. This is our string. If, for example, you need to write multi-line strings, then we use something called a triple quotation marks. And the way it works, I'm just going to delete everything here, is you type 1, 2, 3. So there you go. You have triple quotation marks. And then we are going to write our code, Houdini, and then I say this is a multi-line string. This is another line. And then you finish with the triple quotation marks again. So 1, 2, 3. And now if I print this, my underscore string, you'll see that what we have here is what's going to be printed. One word of caution is that if you have any what's called white space, that's also going to be printed. And what I mean by white space is if, for example, we press the tab key a couple of times, what we have here is going to print in here as well. So click apply, and there you see. So it's something to keep in mind. Usually when we use the triple quotation marks is when we are doing something called a doc string to create documentation for a class or for a function. We will use triple quotation marks. If you want to create a new line, then we use something which is called a escape character. And the way it works is you start with a single quotation mark or double quotation mark. I'm using single quotation mark in this example. And then you write your text, and then you're going to press the backslash and then N for new line. And then you bring your text back here, and then the same thing for the next line. So backslash N for a new line, bring it the line here, and then remove the triple quotation mark and just leave it here. So now we are going to get exactly the same result as we got initially with the multi-line. So this is one option instead of using the triple quotation marks, precisely because that's used to doing documentation. Now cleaning up the code a little bit here, just let's keep it Houdini. One thing that we have, and I mentioned, is that you can check the length of a string. And the way that you can do that is by using a function called len. So len, and then between parentheses, you are going to put the variable that you want to check, and when you click apply, you'll see that we are going to get 7 characters. Why is this useful? Well, this is very useful when you need to check if the information that the user is giving to you is valid. For example, a password. So if the password needs to have at least 8 characters, you need to check if the string has 8 characters. So the length is precisely to do that. It's also a great way to check if a variable is empty. You're supposed to type something, the user didn't type any information, so the length is going to check, well, is anything inside here? If not, it can throw an error. Now, on the next topic, we want to cover what is called concatenation, indexing, and slicing. Let's start with the concatenation. So what it means is that you can, let's say, merge 2 strings together. For example, if I say my string is going to be equal to Houdini, and then I'll say my second string, it's going to be equal space is cool, you can use the plus operator to merge these 2 strings together, and doing that is called concatenate. So what I'll do is my string, remove this here, then plus the second string, it's going to concatenate this. So Houdini is cool. You may be wondering, why is this useful? Well, because there are a lot of situations where we are going to pick, for example, a path. We're going to split that path using the split method. We're going to change the information inside, and then we need to merge everything together. Or, for example, we have the project codes along with the shot, and we need to get those 2 elements together. So using concatenate, you can do that. Then we have what is called indexing. And what indexing means is that each letter or each character inside the string is going to have a value. So if I pick up the Houdini word, the H is going to be 0, then the next letter is going to be 1, 2, 3, 4, 5, 6. So that means if, for example, I want to grab the first letter, I need to use the index 0. Let me show you how that works. If I remove this section here, for us to have access to the index, we're going to use what is called the square brackets, and then inside we put the number that we want to use, so 0 for the index 0, and then when I print 0, this is going to get the letter H. If I want to grab, for example, the last letter, instead of having to go and just counting how many letters I have here, I can use the -1 to have access to that information. So if I click apply, it's going to get the letter I. Why is this useful, you may be wondering? Well, let me show you a practical example. If I copy and paste this here, let's say this is some variable. It's going to give us the project, it's going to give us the shots, and then it's going to give us a couple more information. If we want to have access to the information here, one thing that we can do is using the slicing. And to work with slicing, we have the string, and then we have the square brackets, and we provide the start value, so the index we want to use. We use the column, and then we provide the end. And this is going to read the string that we have, and based on the information or the numbers we provide, it's going to return back the values inside this slicing. One thing to keep in mind is that the start is inclusive, so if I say 0, it's going to include the P, but the end value is exclusive. So it means that it's not going to be included. We'll see that in a second. So if I remove this, and if I say, well, I want to have access to the project code, in this case, it's going to be proj. So what I can do is I can start with 0, and then I put a column, and I want to get the proj. So if we start with the P, this is going to be 0, 1, 2, 3. But remember, if we put here the number 3, and I'm going to show you what's going to happen, click apply, we just get pro. And why? Because the end value that we have here, it's going to be exclusive. It's not going to be included. So if we want to include the letter J, we need to provide the value 4, which is the value for the underscore. So if I do that, now we're going to get the proj. So there you go. So this is how slicing works. So let's do the shot. We know that the underscore is the value 4, So we don't want to include that. We want to start with S, which is going to be 5. So if I remove the 5, so if I remove the 0 and I put the 5, now I'll just go here and say 5, 6, 7, 8, because again, the end is exclusive. I need to include the 9 for the underscore so I can get shot. Click apply, and there you go, you get shot. We also can use something called negative indexing. So if we want to get access to the last values that we have here, then what we can do is we can use the -1, 2, 3, and 4. If you do -1, we are going to get the 0. But then the issue that happens is that if we go to -1, -2, -3, if I put here -3, we're going to see the issue here in a second. Click apply. You'll see that we only get 11. Why? Well, again, because the end for the slicing is always going to be exclusive. So how do we solve that? Well, we just remove the number, and it'll say we want to include everything from the back until the value is -3. So if we could do that, there you go. And this way we get the correct value. However, one thing that I want again to highlight is the fact that the information that we have here is immutable. We cannot change. It's true that we are getting access to 110, but that doesn't mean that my string now is 110. Actually, if after this, if I say print, and if I say print my string, we are going to get the exact text that we have here. So I click apply, you'll see that 110, that's the value we get from the slicing. But then if we just print my string, we are going to get the initial value. What you need to do is creating a new string, and then this new string is going to be equal to the my string with the slicing. And then when you print both, now we're going to get what we need. We have one variable that contains the new string with the updated value, and then we have the old string which can never be changed, so it's not going to change. Now let's clear our board and we'll create a new Python shell so we can talk about what is called a string method. So what exactly is a string method? Well, string methods are a group of functions that we can use to manipulate the strings. And a quick way for us to see what is available is by using a function called dir, and then inside the dir we are going to put the my string. Obviously, keep in mind that what we're going to see next is related with strings. If this was an integer, then the output of this dir would be completely different. But you can have access to the same information. So if I say print and then dir, you'll see now we're going to get a list of all the methods that we have available. For now, you can ignore everything that has a double underscore. We're not going to use that, but everything else is what is called a string method. And how do you use these string methods? Well, for example, let's start with the first one, capitalize. So if I remove the dir and remove this parenthesis, the way you have access to this is by putting the dot and then you type capitalize, and let's not forget the parenthesis. And now if you click apply, you'll see that our text change. Now instead of having everything with capital letters, we start with proj with a capital letter, so capitalize, and then everything else in terms of text is going to be lowercase. There is also another one which is quite useful. For example, here if I put some space, if you want to remove this space, because sometimes this happens, you are gathering, for example, the assets inside a folder, and for some reason there are situations where you're going to have a space, and this is going to throw an error if you want to use that path into a file node, for example. Okay, so if you want to remove that, there is a couple of options. In a situation like this, where the white space is on the left side or in the beginning of the string, you can use the L strip, and then if you print this, it's going to remove that white space. If it's on the right side, you can use the R strip, and then if you're like me, just to make sure everything is fine, you can just use strip, and it's going to remove both on the left and on the right side. So if you click apply, there you go. Then we have another one called replace. Now replace is a little bit more complex because we need to provide some information. So we need to provide the word that we want to replace and then what we're going to use as a replacement. So for example, if I want to replace shot and then put a comma, and then we can say sequence, for example. So now if I click apply, it's going to change shot for sequence. Again, remember that although you're making this replacement, this is not going to change the initial string. Right? The strings are immutable. You will need to create a new variable and then put this inside in order to create a new string with the correct information. So let me just remove the white space here, and let's go to the next one, which is very useful when you need to check if the string that you have, it starts with a specific letter or a specific word. So for example, here you can type starts with, and then you need to provide what you want to check. So shot, and obviously this is going to say false because it doesn't start with shot, it starts with proj. So if you replace these, there you can check and it says true. And then if you don't want to check the start, you can check the end as well. So just instead of start, you say end, and then you can do the same thing. If you replace this value with this, you can say apply, and it's true. It ends with 110. Another one which is quite useful is the find. And what the find is going to give us is not either true or false, it's just going to give us a number. It's going to give us the index. And the index that we're going to give the number 14 is the lowest index of the substring that is found. So if you check the number 14 is going to give us the number 1. So this is a way to see where the word that we want to find, it starts, and then based on this information, so index 14, we can get the rest of the word if we need to, or just a quick way to check that it exists, because if try to find something that doesn't exist, ABC, we're going to get -1. This -1 doesn't mean that the ABC is at the end of the string, it just means it doesn't exist. So it's a quick way for us to see if a specific word or specific text exists inside this string. Then another one which is also useful to check information is the isDigit. So for that, I'm going to put this variable called my_int, and the value is going to be 10. And then what we can do is using the isDigit, and here we're going to replace my string with my int, and we click apply, it says true. So this means this can be then converted into a float or into an integer. And now the final one that I want to cover is the split method. And the split method is extremely useful. I'm going to use this quite a lot because the split method, what it does, it allows us to split the string based on the character that we want to use. So for example, here we have an underscore that is going to separate each of these values that we have. So proj, shot, 0, 10, and 110. So if we want to get access to all of these elements without having to use, for example, slicing, we can use the split method. And the split method, the way it works is we type split, and then we open parentheses, and then inside the parentheses, we're going to use the quotation marks and close with parentheses. And between the quotation marks, we need to provide the character that we want to use to split the string. So in this case, I'm going to use the underscore, and then what we're going to get back is no longer a string, it's going to be a list. See what happens when I click apply. It's not giving the correct value because I have to copy here my string and not the my integer. So click apply, and there you go. So what we have here is a list, and this list has these 4 values that were created through the split. And then what we can do is, let me just copy this as an example. Using also methods that exist to work with lists, we could change the information inside of this list. And then we can use another method called join to convert the list into a string. So for example, if I say my list is going to be equal to this, so then we can use a couple of methods specific for lists that allow us to change the value here. And then finally, what I can do is I can create, let's say, a new string, and this new string is going to be equal to, and you can first of all define that is a string, and then you'll say join, and then between the parentheses, we are going to add my list. So now, if I print my new string, there you go, you'll see that we grabbed all the information inside here on my list, and then we join it together into a string using the join. If you put a space, we are going to see a space between the different elements inside this list. And then in this case, if we put the underscore, there you go, apply, we get back to something similar here with the updated information. And there is much more that we could cover. I mean, we just mentioned a couple of them. I thought that these are the ones we tend to use more and the most useful, but my recommendation would be, since you're learning Python, to go over all the methods that we have to work with strings and see what you can do with them. It's just a good practice. And my recommendation would be also go to the DoubleTree School's website. They have a list with all the methods available to work with strings, with a little explanation what each method does. Another alternative is for you to use the help function. So the way it works is, let me remove my string, you type help, and then between parentheses, you put your variable, and then you put, for example, let's say the split method, okay? So it starts help, open parentheses, you put new string dot split, close the parentheses, and then when you click apply, you'll see that we're going to have some text here that explains how do you work. And my apologies, because I think I made a mistake here. You're not supposed to put the parentheses, so it's just dot split, and then when you click apply, there you go. So now split, it gives you the information on how to work with this method. If, for example, we check the capitalize, we're going to get something similar. So you'll see the capitalize method, how it works, and more specifically, make the first character have uppercase and the rest lowercase. So it's a quick way for us to have access to the help section and understand what you can do with each method. And again, you don't put the parentheses, that was my mistake. You remove it, you just have the name for the method to check that information. So on the next topic we're going to cover, I'm just going to create a clean slate again, a new Python shell, remove this one, and then I can remove basically everything that I have here. And in my string, I am going to leave this value here. I'm going to create a new string. This is going to be equal to 10. We briefly covered this when we talked about working with variables, but I want to mention this again here. When we are working with strings, we can do some arithmetic operation, basically adding. That's what you can do. You're not allowed to subtract a string from a string, but you can add strings to strings, which is called concatenate. And if I do something like this, where I say print, and then if I say my string plus the new string, you know that this is going to give an error, right? Because it's going to say you cannot concatenate or merge a string with an integer, or doesn't matter if this was a float, we'll get the same issue. So one thing that we can do, and we talked about that, is casting or converting a number into a string. What we can use is the str or string function, and then when we do this, and if I put here a space and click apply, so there you go. We have our project shots 0, 10, 110, and then we have a space and we have the 10.0. So this is a way for us to convert a float or an integer into a string. However, there is a better way for us to do this using something called a string interpolation. And the string interpolation is a method used to include variable values within a string. It allows us to create strings that dynamically incorporate values without needing to concatenate multiple parts manually. So let me show you what that means. The first thing you do, you start by defining this interpolation using the F string. So you press the F key, and then you start and close with the quotation marks, and there you go again. I should be using single quotation marks because this initial string has a single quotation marks. And then inside the single quotation marks, we're going to type this is my number. Instead of having to do something like this is my number, and then plus str for the string, and then new underscore string. Instead of having to do this, all we have to do is using the curly brackets, and then inside the curly brackets we are going to paste the variable that we want to interpolate. And then when you print this, we're going to get this is my number 10.0. So we don't need to be doing any casting, we don't need to be doing any concatenating. This is a great way for us to incorporate any variables that we have into a string. I'm just going to show you the old way of doing this, because you may come across with the same principle but done in a different way, and it can be confusing. And basically the way it works is you still have this is my number, and then you remove the new string from here, and then what you do is dot format, and then between the parentheses you're going to put the variable that you want to include, and when you click apply you're going to get the same result. The new way is by using the f string. You completely remove all of this, and then inside the curly brackets you just paste the variable that you want to incorporate. The reason why I show you this option here is because you may come across with this and now you understand that they're basically doing the same thing, but I'd say the new way of doing is starting with the f, and then you put the information inside like I am doing here. So something like this. And I'll say that this is basically what we need to know about working with strings. We saw the different ways we can declare a string using the double or the single quotation marks. Remember that you can work with triple quotation marks if you need to do a multi-line string, but it's better to use the escape characters where you have the backslash with the n to create a new line, because the triple quotation marks are reserved or mostly used when you want to write documentation for classes, functions, and model. Then we touched a little bit the concept of slicing. So you have your string, and then you start with the square brackets. You put the start value that you want to use, the column, and then you put the end value. Remember that the end value is not going to be included, it's going to be excluded, and then you close with the square brackets. And this way we can isolate sections of the string and get that information back to us. And then we saw how we can work with string methods. We cover a couple of them, which I think are the most used and the most useful. But again, just to highlight the point of go back and check what every single one of these methods they can do and how it affects the strings. And then finally, we briefly saw that we can use the string function to convert a variable into a string. But a better way to do that is by using the format string, where we just do some string interpolation. Inside the curly brackets, we put the string that we want to use without having to casting or converting into a new string. And with this,